Hello my dear students. In our last video I am already said that in our next video we can discuss about a very interesting topic, Lorentz transformation equations. See, Lorentz transformation equations. We know already Galilean transformation equations in our in our last semester. See, based on a new concept of invariance of light velocity in free space, the new transformation equations were discovered by Lorentz and are known as Lorentz transformation equation. Lorentz, it is a scientist name, based on the velocity of light in free space. So we invented the Lorentz transformation equations. This is the figure. See, O and O naught are origins, x, y, z, x dash, y dash, z axis. This is a system of in a free space. This is O and this is O dash. Just remember this figure and I will explain now. See, consider two observers O and O dash in two systems, S and S dash. See, S and S dash are two systems with O and O dash as origins. S dash is moving with a constant velocity v, constant velocity v, relative to the system S. The S dash is moving with a constant velocity v with S along the positive x-axis. See, positive x-axis. It moves along in positive x-axis only, not in y and z direction. So y and z's are 0 here. Suppose origins both O and O dashes are of S and S dash just coincide at the time t. Before starting the movement, both O and O dash are coincides at origin O at time t. Suppose when both our origins are coincide, that time suppose a light pulse is emitted when O and O dash coincide. The light pulse produced at a time t is equal to 0 will spread out as growing sphere. Growing sphere is nothing but it moves along a direction, x direction. Now the radius of the spheres grows with the speed c, is nothing but the speed of light is equal to c. See, when the both O and O dashes are coincide here, the light is on like sphere, the light is spread up. We consider in x direction only, and the speed of light is c. After a time t, see, after a time t, observer O will note that the light was reached point P. X, Y, Z. These are the coordinates at point P as shown in the figure. Okay. Now for observer O, at the distance of the point P of XYZ is given by R is equal to C into T. T is time and C is the speed of light. From the figure, R square is equal to X square plus Y square plus Z square. In the vector we already see this. From the figure, the vector R is given by R square is equal to X square plus Y square plus Z square. Now similarly for observer O dash. Similarly for the observer O dash, the distance of the point P of XYZ is given by, here is R dash, the speed is same, T is T dash. Now R1 whole square is equal to X1 whole square plus Y1 square plus Z1 square. Also for time, see, this R dash is replaced by CT dash. Now CT dash whole square is equal to X1 square plus Y1 square plus Z1 square. This is equation number 2 and this is equation number 1, and this is for observer O and this is for observer O dash. Since equation 1 and 2 must be equal because both are observe same growing sphere. See, here both are seeing the same sphere, right? The same light. So both are equal. Equation 1 and 2 are both are equal. Now write that x square plus y square plus z square minus c square t square is equal to x dash square plus y dash square plus z dash square minus ct dash square. Since there is no motion in y and z direction of the s dash frame, so therefore y equal to y dash and z equal to z dash. I am already said that there is no moment in y and z axis, so y equal to y dash, z equal to z dash. The only direction in the x direction the moment is there, so y equal to y dash, z equal to z dash. Now the equation 3 will be, so both x equal to y equal to y dash and z equal to z dash, both are cancelled, so consider only x values. We get this x square minus c square t square is equal to x dash square minus ct dash whole square. Now the transformation equation related to x and x dash can be written as, the transformation equation for both x and x dash can be written as, see, x dash equal to x minus vt. This is from Galilean transformation equation. Using this you can write x dash is equal to k into x minus v into t, equation number 5. Here is k is a constant. Now see, for using of this equation number 5 is for must, see, reason for trying the equation number 5 is transformation must be reduced to Galilean transformation for low speed. See, v is very less than c. When the velocity is very less than light velocity, that time we can reduce transformation equation to the Galilean transformation equation. Similarly, let us assume that for t dash is equal to a into t minus b into x. This is equation number 6. Here is a and b are constants. Now substituting values x dash and t dash in equation number 4. Here is the equation number 4. Substitute x dash and t dash values in the equation number 4. So from 5 and 6, now we get x square minus c square t square is equal to k. This is the value of x dash, and here is the value of t dash, and we multiply a minus b whole square like that, and after simplification we get x square into k square minus c square a square b square minus 2xt into k square b minus a square b c square minus c square t square a square minus k square b square divided by c square. This is the try this mathematical steps. And now compare the coefficients of corresponding term. See, x square is there and corresponding coefficient, 2xt is there, corresponding coefficient, c square t square is corresponding coefficient. Here is k square minus c square a square b square is equal to 1, and for this is equal to 0, and for this is equal to 1. For coefficient of x square, coefficient of 2xt, coefficient of c square t square. This is equation number 8. And now after solving the equation number 8 for a, b and k, we get k equal to a is equal to 1 divided by square root of 1 minus v square by c square. This is equation number 9. And b value is b by c square. This is equation number 10. So both 9 and 10, substituting the value of k, a, b in equation 5 and 6. Now we get, see, k is also same, b is also same. Then now we put these equations and these values in equation number our 5 and 6. We get x dash is equal to x minus vt divided by square root of 1 minus v square by c square, and t dash equal to t minus vx divided by c square square root of 1 minus v square by c square. We get two equations, right? These are the Lorentz transformation equations. So 1 and 2. For y is equal to yz, y dash is equal to y, z dash is equal to z, is right. For x dash is equal to this one, and the fourth term t dash is equal to, for time, for the equation is this. Now we get Lorentz transformation equations, right? Now inverse Lorentz transformation equations, inverse of these two. What we do for we get an inverse for these two is interchanging the coordinates, and second is replacing v by minus v. From this we get inverse Lorentz transformation equations. X is equal to this and t is equal to this. Just we replace coordinates and interchange the coordinates, and v by minus v. See, this is the minus v is replaced by v is replaced by minus v. Minus into minus, it becomes plus. Also here it becomes plus. The y is y dash is equal to y, z dash is equal to z, is same for inverse also. And this is about Lorentz transformation equations.